What we're going to do is return to our network quantities panel and customize our count files so that they'll include the head walls and the RCP pipes. So first of all, we're going to customize the manhole depths. I'm going to select on the folder icon and come down and select Open. Now, the way the count procedure works is it's made up of count lines. Let's take a look at the first count line. This says we're supposed to add up all of the manhole types AL2D that are in a depth range between 0 and 1.5. And once again, you can see that there's the 1.5 to 2. At the very last one, we have everything between 7 and 999. Now that would be very, very deep manholes. And the last one we have is just by chance if some of our manholes were above ground, this would count them there. Moving down here, there's the one that adds up the sags for us. Here's the one that includes the manholes. Now you'll notice that this one has got quotes around it. It's not required in this case, but if your manhole type ever does have a space in its name, you are going to have to include quotes around its name. Finally, there's the little section that asks for the totaling for all the ones that were missed up above. Now if we wanted to change this so that it added our head walls as well, we could come down here and add one more line. Now let's say for this one that we're not interested in the depth at all, we can just type in HW for our head wall, anything between 0 and 999. Now also we'll do that same trap just in case there happens to be some above the ground, which of course there shouldn't be. So head walls between minus 999 and 0.0. Now there's a very important factor about all of these count files. This system is designed never to count a pipe twice. So there will be no double counting anywhere inside the system. So if I was to add another count line after this saying head walls between minus 999 and 999, I would always expect that third line to be 0. Now it will not recount those because that range has already been counted. This one will definitely be 0. Alright, then let's go save that. We'll write that out. And let's go change our pipe depths as well. Now inside the pipe depths, what we didn't count was the RCP type pipes. So if we want to include that, you'll notice that these count lines do not have 3 items in them, but rather they have 4. If you have 4 items, it's the flag to 12D that you're interested in summarizing by size as well as by depth. So here we're asking for the class 2s, 375s, 450s, and 525s. And then if there was any other sizes that we missed, they'd get added up down below. Now if we wanted to change this so that it was going to add up our RCPs, what I would do is copy that entire section, paste it in down below, go back up to the top of it, and then we just have to do a search and replace to replace the 2 spaces with an RCP space, and go replace. And what it's going to do is move down through our system and replace all of our class 2s with RCP. So as you can see, it's just a matter of going through. I'm going to go one by one just to make sure that I don't change anything that I wasn't planning on changing. Change them all. That's perfect. So let's close that. We can close this, and yes, we definitely want to save it. And we can go do our recounting. Now you probably noticed that the last time we did our report, it was full of 0 values. That was because of this tick box here, so I'm going to turn that off to make our report a little bit smaller. And then we're going to select count again. And no, I don't want to append. I'd like to replace this, so I'm going to go for the no button and go back and open that report again. When I go back and open this report, this time you're going to see that we've counted our AL2Ds as before, the manholes, but this time we've got the head walls included where we have one of them. Now we've got our totals down below. What's significant here is that we don't have the wild card. We haven't missed any. If we go down to our pipe sizes, we have our class 2s and our RCPs. But if we come down here, it says that we've still missed. We still have some wild cards that we have not counted. So if I come down here and find out there's everything that was counted, the types we used were RCPs, class 2s, and class 3s. Alright, so that was what the issue is, that we haven't counted our class 3s. So if I returned and customized our list one more time to include those class 3s, then we would eliminate all the wildcards and we'd have the totals for our network. In addition to the drainage defaults, there's also 12D defaults that can be set that control your string settings. Moving up to the project menu, down to management, and across to defaults. The two defaults that I want to look at on the system is first of all the color of the strings. If I was to change the color to magenta, any new drainage strings that were created would be magenta in color. Also, I'm going to go down to the text height. 6 pixels is a fairly small piece of text, especially on high resolution screens, so I'm going to update this to 12 pixels so that the screen text is just a little bit bigger. Selecting the set on this will update this for our project. If we were to select the right button, we could write it out to a defaults.4d file so that it would be effective for all the projects in this working folder. If I was to put it out to my user folder, then it would affect all projects started on this computer. That's not what I'm planning on doing, so I'll just finish that, and I'll leave it with setting for this project. And then finish. Throughout using 12D, you're going to have this reminder come up to save your project. We'll select yes. 12D has a very intelligent system for saving your data. If you're working with a very large project, it will save only the data that you've changed. So you might as well select save because it's free. The first drainage layout that we're going to use is going to be imported from a drawing package. Moving up to File I/O, down to Data Input, we're going to move down to DWG DXF. The drawing file that we're going to read is going to be our drainage data file. Now every layer that's inside AutoCAD becomes a model inside 12D. In order to keep all of these models together, we're going to use a prefix. The prefix in this case is going to be DWG space, and that way each one of the 3 layers will be kept together inside the 12D model list. The rest of the defaults are adequate, so we can go down here to read. Now make sure you only press the read button once because you do want to have only one copy of your data. Then select finish. Now if I go up to my plus button, you'll notice that we've read in 3 new file models, each one of them beginning with the DWG prefix. Now the first one we would like to look at is the DWG drainage network, so we're going to add that on to the view. Now with our tin in the background, it's a little difficult to see the network, but what we have is 2 branch lines coming across the road and 1 trunk line coming along the southern side of the road. Now when these were drawn inside AutoCAD, there's a few rules that were followed. First of all, the strings were drawn in the direction of flow, so they were drawn from upstream to downstream. The second rule is that when the trunk line was drawn, it was drawn with a polyline, and every vertice on that polyline becomes a structure inside 12D. So there would be a vertice at the beginning of the line, of course, but there was also a vertice on the trunk line where each one of the branches came and joined. The next thing that was done is when these branch lines were drawn, they came in and it was definitely a point snap drawn onto the trunk line. With that point snap, we create what's called a junction pit inside 12D. The strings that we've imported from our drawing package are only 2D strings. They're not our drainage strings. If I was to press the F2 button on my keyboard and select that string, you'd see that the type is a superstring and the Z value is down at 0. Now to convert these to drainage strings, do not use the strings convert. Instead, go to the drainage menu and select the Create from Strings. All of our 2D strings are contained in one model, so we'll select that model, come down here and select DWG Drainage Network. Now we do not want those superstrings in the same model as our drainage strings, so we're going to create a new model called Drainage, where our new drainage strings are going to reside. Select Process. It tells us that 3 strings were loaded and converted to drainage lines. So we'll finish that. To take a look at these new strings, we'll go to the plus button, come down and add on this drainage model. You'll notice that the drainage strings are created right on top of the other strings. We've got our manhole shown at where the vertexes were, and where the single line was, we now have 2 lines showing the width of the pipe. As an alternative to creating your drainage layout inside a drawing package and bringing it into 12D, you can draw your drainage strings inside the 12D package. When drawing them inside 12D, we ask you to follow the same rules to draw them from upstream to downstream in the direction of flow. We also ask you to draw the pipes where they really are in the ground. The reason for this is that we measure the cover directly above the pipe, and we want to ensure that your invert levels are set correctly. Secondly, if you have service clashes, services that cross your drainage network, we want to make sure that we accurately measure the distance between the service and the pipe. You will often be requested for set-out coordinates for your structures. Let's zoom into the structure that we have here. We've just asked you to place the pipes where they truly are in the ground. The center of the intersecting pipes may not necessarily be the X, Y, or Z value that you want to quote for construction. 12D uses what are called set-out points. These set-out points can be obtained from your road design strings. Therefore, your manhole or your structure can be linked to your lip of curb, back of curb, top of curb, and the X, Y, and Z values taken from these points rather than from the center of your pipe intersections. We are now ready to create the 12D drainage string. Selecting Create from the Drainage menu, we'll give the string a name. We'll call it string number 1, and we'll put it into a separate model called Drainage 12D. You'll notice that the default color comes from our defaults that we set earlier. The flow direction says the direction is going to be in the same direction we draw the string. Our finished surface is combined, and we'll turn on the extra tick box for many strings. This will make this Create panel reappear once we've finished our first string. Selecting the Create button takes us into the Drainage Edit panel, and we want to go to Edits, Append to put down our first manhole. Selecting Append plus Radius would allow us to have a curved pipe. So, add append. I'm going to zoom back out. You'll notice that we now have a manhole symbol and a circle attached to our cursor, indicating that we are creating a drainage string. Now, it'll be a little bit difficult with our tin being shown like this, so I'm going to turn off my tin combined and my tin design, and that will allow me to see the drainage strings a little closer. Now the idea here is that we're going to place our pipes directly beneath the back of curb strings. Now the templates that we've run create a left back of curb and a right back of curb, so we're going to be snapping to one of these two. Now we're going to keep the coordinates about the same where we have our current structures, but once again just making sure this time we have them on the back of curb. The other manholes or inlets were snapped to the invert of the curb. So, what I'm going to do is do a right mouse click and say Find by Name. What this does is ensures that I always pick the correct string the first time without going through multiple snaps. So I'm going to set this to right lip of curb, back of curb, hitting the Set button, and then when I go to pick the string, I hit click immediately. You'll notice that I always get the right back of curb first click. Moving down to here again in approximately the same location, right back of curb, clicking again, right back of curb, coming down to this last one, clicking there, right back of curb. If I want to finish this down to the end of my project, I could come right down to the TP at the end, and once again, right back of curb. And if I was going to go across the road to the other side and want to click again, you'll notice that I'm not getting a snap. That's because this one is going to be the left back of curb. So what I'm going to do is do another right mouse click and go Find by Name, and I'm going to have another set box so that I can set the left back of curb. Hit the Set button, and now I can go directly across and pick, the left back of curb. Enter, and now that I'm finished, I'm going to do a Save and Finish. Now I'm ready to do my second string. I'm going to call this string number 2. Once again, go to Create, and then Edits, Append to start laying down the network. Now this time I'm not going to follow the route before with 2 branch lines, but rather I'm going to go down one side of the road and cut across. Now, this is my my left back of curb, so I don't have to reset my settings. I can go enter to accept. This one I want to make sure that I'm on the TP of my curb return, so I'm going to snap that a little more carefully. There's my left back of curb. And now I'm ready to come across and snap onto my junction pit. Now, to make this a little bit easier to see what I'm doing, I'm going to turn off that drainage and that DWG drainage network so that all we're looking at is the drainage.12d. Now, if I tried to snap now, I would not get a snap on to that point because I'm trying to snap onto the drainage string that's called string number 1. So I'm going to create another find by name, put it up on top here, and it's going to be the one that clears it out. So when I select set with nothing in the box, I've now turned off the snap by name, and I can snap onto any string. So if I click here the first time, I've got my road section. I don't want that. So I click again without moving the mouse. I don't want the back of curb. I'll click again. Now there's my drainage 12D line 1. I do want that. I have the diamond that indicates I have a point snap, and it says point snap in my menu. So that's definitely what I want. Middle mouse click, and I've just successfully created a junction pit. Now I'm finished with my line, so I can come up here and do a save and finish, and then finish as I've completed my drainage layout inside 12D. We're now going to look at moving one of the pits inside 12D. Anytime you have to do any plan editing, we recommend that you go to Strings, come down, and use the Points Edit menu. Now I'm going to be using this a fair amount, so once again I'm going to tear off this menu, and I'm going to use the Move command. So the first thing I want to do is to move this manhole, and what I want to do with this pit is to move it 1 meter upstream of the TP. So I'm going to select this pit, keep selecting until I get the drainage string. There it is. Accept that with a middle mouse. Now I want to use my Snaps Kogo in order to place this. I'm going to do a right mouse click, go to Snaps CAD, and I'm going to use a points locate offset. Now whenever you're using the Snaps CAD, you should follow the instructions that are listed in the bottom left-hand corner of the screen. First thing I need to do is to pick the string that I want to be located on, and that's going to be my back of curb string. When I pick it, I don't want to do a straight pick, but I want to use a directional pick to tell 12D which is the positive direction. So I'm going to do a mouse down here, drag to the right, and when I release, I want to be near my back of curb string. Now you'll notice that is my left back of curb. That's the one I want, so middle mouse to accept it. I've just defined the positive direction being to the right. And with 12D using a right-hand rule method, offsetting in this direction is considered positive. Upstream offsetting to the left is considered negative. Now, the instructions down here say to pick the position that I'm going to measure from. The position I want to measure from is the end of that line at the TP. Click on that, middle mouse to accept. Now, I want to move 1 meter along that line, so I'm going to type in 1 meter and hit enter. And I don't want to move off the line at all, so my offset will be 0. And you'll notice that that manhole is immediately moved to 1 meter along that string with a 0 offset. The option you select to add a pit inside 12D depends if you want to add it to the end of the line or in between two existing pits. What I'm going to do is zoom out here, and first of all we're going to add one onto the end of this string. To add on to the end, we're going to use the append. Come down here, we're going to select our drainage string, drainage 12D, middle mouse to accept. It recognizes that it is a drainage string, so immediately you have that manhole symbol on the end. Now, if I'm coming down, I'd like to immediately snap to my left back of curb. If I wanted to make this nice and easy, I can hit the set for that, come down, select there, and immediately be snapped onto my left back of curb. Middle mouse to accept, and I'm ready for the next one. When I'm finished, I can just select finish, and I have my new manhole. The other option would be to add one in between. For that, I would use the insert command. Using the insert, you'll notice if I go to pick it now, I can't pick my drainage string because I still have my snap set to my left back of curb. So I'm going to turn my name snap off, come in here and pick until I get my drainage string, middle mouse to accept, and I'm ready to insert a new drainage pit. If I want that to go on my back of curb, this time I'm not going to use my name set, but rather zoom in a little bit closer and click on the road strings until I get my back of curb. Now that's my top of curb, click again, that's my invert, click again, that's the back of curb, that's the one I want, so middle mouse to accept. So you can see the advantage of using these name snaps is that when you have many strings, like the road strings, close together in your curb and gutter profile, it makes the snapping much faster if you use your name snaps. Now we don't want to keep those points for our design, so I'm going to undo those changes. I'm going to do first a Control Z to undo that one, then a Control Z to remove the other pit that we added earlier. Now that we're finished our plan editing, I'm going to hit the set on the clear name box so that the name snap has been removed, and close those panels. We're now about to proceed into the vertical editing of our drainage network. This does not mean you cannot return at any time to add additional manholes, move them, or delete them as required. As a matter of fact, we will return shortly in order to split this drainage line, and instead of having it flow along the curb and gutter, have it come across the road to join down here. If we've decided that we do not want our drainage network to follow along the road and then across, but rather come directly across the road, we would have to split this drainage string here and then redirect it so it moves down to the other curb. To do this, we're going to use our string split and join command for drainage. Do not use the strings edit split command. So we're going to select split. The split must happen at a 12D pit, so I'm going to select the pit we want to split, select accept, and you can see that it's been successful. Now the next thing I'd like to do is to use the move command once again to come down and to pick the manhole that's at the end of that string, swing it around, and create another junction pit on the other side of the road. To create another junction pit, I'd have to zoom in a bit closer. Once again, I'm looking for a point snap onto my drainage string. There's my drainage string. I've got a point snap indicated by the diamond and in the information snap. So middle mouse click to accept, and I now successfully split my drainage line, moved it, and created a new junction pit on the opposite side of the road. If we wanted to do the opposite procedure and take this string coming across the road and swing it so that it's joined up with this string down below, we would probably want to do a join command. First of all, we'd have to do the move in order to grab this manhole, select it, bring it across, and create that junction pit as we had before. A point snap, and middle mouse to accept, finish. Now for all the 12D calculations, this would work just fine. The only issue is that when we did long section plotting, it would show up as two different strings. If we wanted to show up as one string, we'd have to do the join. To do a join, we have two options: join upstream to downstream or downstream to upstream. Now the first issue is which string we're going to use to maintain the properties. For example, if this string here was yellow and this one down here is magenta, and I wanted the new string to be magenta, I would select join downstream to upstream. That way the downstream would maintain the properties. Also, before I did this move, this manhole up here probably would have contained all of my catchment areas and the rest of the information. The manhole that was down here as a connection pit contained no intelligence at all. The reason it was there was simply for the connection. Therefore, when I swung it and moved it up here, there's no intelligence on the manhole that's at the end of this string. However, the manhole that's at the upstream end of this string could well truly contain catchments, time of concentrations, and all those intelligence. So once again, I would want to keep the manhole intelligence from the downstream string, so I would select join downstream to upstream. Alright, so let's go ahead and do that then. We're going to say join downstream to upstream, and that's also the order that you pick the strings. So first of all, picking my downstream, then I'm going to go pick my upstream, and it tells me I have a join successful. In order for that join to happen, I would have had to have that junction pit there to begin with. Now that I've finished all my plan editing, I'm going to finish that. I'm also going to close these name snaps. Whenever you do close your name snap, double check to make sure that you've definitely cleared your name snap properties, or you won't be able to snap to any other string other than the name indicated here.